I'm Songhyun Park and I've been working at Line Plus as an iOS engineer. In this session, I'd like to share the 3 different approaches I have been using for the easier player module. The Line app provides many features that has playback functionality. Since the developers are in charge of its features to save more resources, our time and our efforts, we need to implement the playback more easily. For that, what should the player module be like? After some thinking, I've come up with these 2 principles. First, simplicity. We want to have less work to use the player module. This means less coding to play the media. Second, clarity. The player module should clearly show how it operates. This will allow developers to focus on their business logic better. Based on these principles, I have adopted these 3 different approaches. First, player status. Second, UI components. And the last, player pool. So first, let's go over the player status, which can show the playback flow more clearly. In general, when playing media, the flow proceeds as follows. The assets should be set to the player. Then at the desired time, the player starts loading the assets. If the media is available for the player, the playback processing will start by filling the media data in the buffer. If there is not enough data in the buffer, buffering may occur. Playback may be paused due to user action or other factors. When the player plays the media's end time, the playback process will be finished. Errors may occur when loading on assets or processing playback. The AV Foundation provides playback-related properties such as status in preparing, playback rate, buffer health, and so on. And the player module should observe these properties and notifications to manage the playback. By observing and using those, the player module provides APIs about the playback status. Many of the properties can be used, which can drive developers to distraction with the multiple number of properties rather than the playback flow itself. This diagram shows the player status defined with enumeration type that intended to reveal the playback flow. It's clear to show the flow of playback status, enabling the developers to understand why the video stops or why the player renders nothing. And the player status allows the feature developers to handle the code with less effort by reducing the properties that is supposed to be observed into only one. This means that developers can get a relative code into one place. Moreover, maintaining the player module can be easier because the player status can give you some hints on how to handle the changing properties of AVPlayer item or AVPlayer. To make this happen, the player module should be able to update its status value accurately. The second approach is about the UI components. There are UI components commonly used when handling playback. Control view indicates the status of playback and manipulate the player according to user intention. View controller displays media on the full screen. Transition handles animation when switching full screen. And other components may be used. Here is sample code of UI components on the left side. I won't go into detail on each line, but you can see that if the player module provides a default UI component, implementing UI can be done with less code. However, we won't use the same UI everywhere, so it's good to consider the extensibility. What I've provided in the control view is that the developers can adjust the margin or add a subview to a specific area. But providing too many options can increase the code complexity within the module, so be careful to provide them at a reasonable level. The last and third approach is about player pool. Sometimes we need to create and use multiple player objects. For example, when playing multiple media on a list, preloading and keeping media data is needed for providing playback with a low latency. Video playback needs quite a lot of device resources, so we need to manage the player objects well. Keep in mind that using too many objects can cause memory issues and the error which occur when every decoder is busy. These exceptions should be handled by releasing unnecessary media, but if each feature manages the player separately, it will be difficult to get all the player objects to find the player which has the unnecessary media. So I created the player pool using the object pool pattern. In the features requiring claiming media, the player object is not created directly, but can be obtained by sending a request to the player pool. In the player pool, all created player objects are appended to the list to manage. By managing the list of all players, it enables the player pool to easily handle exceptions like memory warning or a cannot decode error within the player module. Also, it allows the application to limit the player objects, limit the number of player objects that can exist at the same time. And player pool can reuse inactive player objects. By using this player pool, the feature developers don't need to manage the player objects since the player pool handles that. To sum up, let's review the three approaches that have been discussed. First, by defining player status and showing the playback flow, we can understand better how the player module works. Also, UI parts can be implemented with little code when some of commonly used UI components are provided. Last, the handling of exceptions is made easier by managing objects inside the player module using the player pool. I hope this has been helpful to all of you. Thank you.